This video will talk about reading the Keysight M8070B Logger window events with Python. There are times when you're programming when there's an issue based on conflicting settings or dependencies that may not be available or allowed. And the error would show up in the message window, so right here. So this is an example of one of those type of sequences that could happen that could generate this. I could do this through the GUI. If I have set channel 1 to pulse type through the patterns, if I go select pattern and pulse, selected that and made that pulse, but then I tried to change the coding to PAM4, you would get this error because it is not allowed. It's an disallowed feature. The second thing is you can clear this and read this in the GUI when you're operating the GUI, but what happens when you are doing it programmatically? So that's what this video is about. How do you read this information and how do you get these message queues that come in here? Because if I generated this again, let's say I tried this one more time, it would queue up another error, and there would be lots of errors in there. We could clear those out and make them go away, but we do want to know that they happened and try to do something in our code to fix this. I have a couple of examples of how this gets fired off. We have Command Expert, we have the Keysight IO logger, the IO monitor. So as you noticed, nothing got logged when I was using the GUI. That's because the program makes these settings through .NET or some other method that the bird handles directly. Now, if we go in and want to run this with Command Expert, we can see that this does occur, and we can also try it in Python code. So I'm going to show the walkthrough of the Python code. I've got a simple walkthrough doing these exact things. We took a sequence that we created in Command Expert and run it here. We connect to the instrument itself, do an IDN sanity check to make sure that things happen. Let's just clear this out so we aren't confused. And then we can go on. Let's start here. Let's go into debug mode and step through what we want to do. We are going to run in debug mode. So we should stop at the first command. And I will step over and continue. And we'll see these commands get executed up in the Keysight IO monitor as we execute them. We're doing the IDN, so we did IDN here. We do get response back in our IDN string here in the debugger, and we do see it up here. And we're going to run the test case, sequence set M1 data out, set pulse type, and when I hit this, it's going to fire one here. I'm just going to clear these commands. So we see it fire here, and we will see it come up. We'll see the command there, and there we go. So we fired that off. However, we don't see anything in here. That's because we haven't dequeued it, or we haven't even read it, but it does exist. So what we need to do is go in and do a system error next and system error count. So first we'll do system error count, and we'll read that value back. And we do that, and we did a system error count here, and we see that it returned 1. So there's 1 in the error queue at this point in time. The next is we need to read the message. The interesting thing, the message comes back as a list, so we kind of have to glue that list together in Python. But let's pull that. The error we pulled back is up here again, and we get 300 device-specific error, M1 data out, block 1, and so forth. So that all goes down here. We see that also down here as well. And then we can glue it together and print out that error text. We can continue on. Oops, cancel. Let's actually step over, run that. So we are now filling up the error text by populating that. And when we're done, we're going to print that error text. And then we're going to read the error count again, and the error count is now 0. So let me run the code again so we see everything in the normal window here. There we go. That's the code running. Case fails when we tried to set the pulse mode and then turn on PAM4. So we did read an error count of 1 initially. We read the error text, and afterwards the error count, it dequeued this, and now there's 0 messages. Now there is the case where you might fire off more errors, and if I did that, for instance, let's simulate 3 of these when we run this code, and it should show that there are 3 errors left in the queue that we haven't decommitted. What I've done now is added in, I had to get my window back that I can see what's going on. Let's clear that window. Let's now run it with 3 queued up, and we'll basically run that and see that we will have errors left when we only read 1 message. Okay, let's run that. We generated 3 messages. We only read one back, and we did decrement the error queue by 1, so we still have 2 left. So we would have to go back and read those all. Now, you could get a bit more fancy with this. I do have some code that demonstrates an example where we can dequeue a number of them at the same time. So we would read, well, we can queue up a handful of these, and then we can process the error queue. Let's just run that. Okay, so what it did was essentially read the error queue, read that same code that we did in the simple example. However, now we're decrementing each time, and we're looping through until that error count number reads 0. So now we're reading all the ones in the queue, and that way, that's the way we can dequeue it. It's kind of the same as doing this up here, but we have no way of clearing that window in the GUI through Skippy. There's just no command for it. So, but this code, let me show you where that is written. There's a small routine: process error queue while total error count is greater than 0. What we do is we read the error count, get the number of the total errors, and do a while loop on the total error count, and then go through the same process of basically dequeuing the count and extracting the values and then printing the text for each one in that case. That's an example of how to use this more intelligently, and I'll post the code for all this. There's a small GitHub project that you can extract this information from. The other thing I wanted to talk about is the logger file. So the logger file is whenever you start the M8070 software up here, it generates a new logger file in the users. In my case, it's Fairfield, app data, local, Keysight M8070, and then it has a list of files. If I was to go and open that folder, let's just show open containing folder in Explorer, that will pop up. And when we do that, there are a number of tests. So there's a number of runs I've done. What you want to be doing is looking at the absolute latest version of this. And I'm going to show you some code that even looks for that for you and share that on the GitHub project. But it's here. What you want to do is open the latest one, which I've already done here. And in here, right from startup of the instrument, you get a lot of information. There's system info, there's something about the operating system, some licensing, things like that. Some diagnostics are in there, but what we really care about is looking for these errors, for instance, that come in that case. This is an example of that. Error instrument. So this is the timestamp. This is the command or the response type, which is either error, debug, system, or info. And then there's instrument and then the message itself. So this is a case where I shut things down. If we go back into that queue in the File Explorer, I should actually be looking at the latest one, which let me pull that up and open with Notepad++. And we should see our last bunch of errors. I've been testing this for a while, but we get the timestamp. So that's really important because then you can tell, was it a recent error or was it an error? Maybe you've been running this for 24 hours and this is an old error from when you early on. You don't know. This is great because it does dump all this information. So we can parse this if we want more information. Sometimes there's a bit more information in here, but you do get the error history. If I clear it out here, it doesn't mean it goes away. Let's go and see what happens if I try to change this pattern to pulse, because that's also not allowed while PAM4 is on. So it generated an error. I click here and it shows that it happened. So this happens at 4:06 p.m. This is 4:06 p.m. So you see a GUI created error also shows up in the error log. If I do my simple walkthrough example, let's right click and run that. That's going to queue up another error. There you go. We queued up a handful of errors. So we click here and this log file now has appended that. It's now 6:06 and 33 seconds. So that does give you even more information if you want a kind of a historical or statistical count of what's going on. I wrote kind of a parsing program. So let's just make this bigger. It's just easier to read. A couple of things I've done here. So let's roll this up. Let's clear this all and let's run this. So we count if error in line. So that's what I'm looking for. Print that because it will tell us that that's the kind of line I'm looking for. But then I thought to myself, well, I'm getting these old errors from like yesterday, or I had this running for quite a while. I only care about the more recent ones. What I did here is added some code to check the time and date. Let's get today's date and time Let's get the time that gets returned here. There had to be a little parsing because it's not exactly the same. So date, time, last error, I had to do a little parsing there. So I used some code. And again, this code's available on GitHub for you. You can go back and check how many minutes since last error. It's probably been at least a minute now. So let's rerun this and we should see 1 minute since last error. So then you could use that since last error or time elapsed since at last error to give you an indicator that something's wrong. For instance, if you had a timeout and you're programming and you go back and see there's an error count that suddenly appeared, you could find out how long ago did that time occur, and is that correlating with your issue that you're having right now. Again, this code is just a simple function call here. You just point it to the folder where your files are put, because again, everybody's username is going to be unique probably, but the rest of this could be used directly. It looks for the latest file that's in that folder, and it also looks for all the errors and then looks for the last error that's in there and then shows the last error as well. So that's the most recent error. If I check again since I've been talking, it's now 2 minutes since last error. It still gives you all the other errors, tells you the most recent, and then it says how long since it's been. You could check for the last 5 errors, something like that. So you could import this into your program and get through it. I hope this is useful to you. If you have any questions, leave them in the comments, and happy programming.